I'm going to introduce the National Materials Measurement Metrology strategy. It's not quite out yet, but I can already talk about it, and you can pre-register to download it. I don't know exactly when, but Stephanie or Andy will tell us exactly when. So yeah, NPL, we're the National Physical Laboratory, the National Metrology Institute, and we've been there for more than 100 years, since 1900, and most countries around the world have got an NMI like NPL. They are responsible for the measurement infrastructure in the country. And we are a public corporation. We are fully owned by DSIT, Department for Science, Innovation and Technology. And as you can see the picture there, that's our laboratories in Teddington, where most of our labs are. But we've also got labs in Strathclyde and Surrey, Cambridge, and recently in Solihull and Huddersfield. So we try to be a truly national laboratory. About 7 years ago, NPL came out of a GoCo arrangement and was set up as a partnership with the universities of Surrey and Strathclyde. And so both those vice chancellors sit on our board. And together we run a postgraduate institute for measurement science, which got about 200 PhD students in, with lots of universities around the UK, a lot with Surrey and Strathclyde, but most actually with other universities like Imperial, UCL, Cambridge, all across the place. So at NPL we've got about 1,200 people working, of which 800 are active scientists along the whole breadth of physical measurements. So we do lots of traditional things, but we've got about 30 research groups. But we look at our impact in national challenges. How can we contribute to the bigger problems in prosperity, in environment, health, and security and resilience? That's how we sort of profile ourselves externally and the impact we can have in that. And metrology plays a really crucial part in all these challenges. It supports the science and research effort. It accelerates innovation. We provide evidence for policy development and regulation. And in the last sort of decade, there's been a real transformation into digitization of measurement, and the confidence you can have in that data is becoming really, really important. So as a national laboratory, there's about sort of like 3 major activities which we undertake. On the left-hand side there, you've got the traditional sort of highest point of reference as the NMI in the country. We run the national timescale, so the atomic clocks are at NPL, and we compare our atomic clocks with other atomic clocks around the world to make sure that there's one uniform timescale across the world, which is very important. And we do that for all the other measurement standards as well, for mass, force, length, you name it. And that's an important part of our activity. You can still come to NPL with a kilogram, and we weigh it for you, give you a certificate, and charge you £500 for it. And that is that's sort of a quarter of our activity is to support industry, and it's a real demonstration of impact and the need of those kind of measurements industry needs. And then a very significant part is now becoming the underpinning of national challenges. So we've got big research programs in, was already mentioned, in quantum technologies. We do test and validation for quantum technologies. We've got new laboratories in Teddington, which are looking at the most advanced next generation optical clocks. I mentioned the laboratory in Solihull. We're setting up a new laboratory to test and validate 5G infrastructure for the telecoms industry, because of course we're moving away from getting that from China and wanting to develop our own sort of national capability in that. And there are new sort of challenge programs coming out all the time, and we apply our measurement expertise to those problems. And of course, as a national laboratory, we are the go-to place for government to do that. And then on the right-hand side, international leadership. Because of our expertise, we sit on lots of international committees. which are to do with standards and metrology with other countries. We do a lot of thought leadership, so we develop strategies and foresighting which we share around the world. And we work with all these other organizations which I mentioned there, FAMAS for materials, Euromet is the European Metrology Organization, and again, the news this morning is very good because that Euromet RMO has got a big program, a Horizon program for metrology research in Europe, which originally was set up by MPL, but of course we've not been in it for the last couple of years, and hopefully we'll get back in it, which will be really really positive. So that is sort of the landscape of what we do. Then how do we use our metrology? And our mantra has become creating impact from science and engineering. We're not, we'd like to say we're not like academia. We don't do research for fun. We do research because it has to have a real impact. And you can see this through the whole of the innovation life cycle, beginning at basic research, where we work with academia through our PhD students and links with university. We are in research programs. We work with industry, R&D organizations to test and validate new technologies because we've got that capability in the laboratory, and then we can use that to demonstrate performance of new solutions and really start to develop product standards for these types of new solutions. And then when technologies are in the market, we can support quality control and compliance and regulation. So there's metrology and measurement science all along this innovation cycle where we are relevant. And then going more specific into materials, it's not really that different, because if you develop new materials, you want to have confidence in the material. You want to be able to you can reproduce this new material reliably. That you have got data which allows the supply chain to use, because there are of course companies in the supply chain which haven't developed the material, they want to use it. And that's basically supporting the adoption of new materials and reduces the risk of companies. So it's really important for investment as well to have confidence in new materials. And this is sort of the life cycle of how you develop material standards. From the left-hand side, as I say, we are involved in the discovery of new materials. So going back to my own research in the early days of graphene, we worked with Manchester on the research in graphene, and we did measurements around the quantum Hall effect in graphene, because of course the quantum Hall effect, as you might know, is the international standard for resistance, which we maintain, and graphene has got a beautiful quantum Hall effect, which we're now using for resistance calibrations. One of the first applications of graphene. But through that work, on the early discovery, of course, we develop knowledge and capability, how to characterize the material, how to measure it, because of course that wasn't very well understood in the beginning as well. So after a number of years, we started to produce things like good practice guides, how to make measurements on graphene, technical procedures, draft standards, terminology, what do you call the different new materials? And that took a number of years before you get to that stage, because it needs to be done on a consensus basis. And then going further, like 5 to 9 years, we start to work with other international organizations like BSI or ISO or IEC to really start developing the first standards. And Andy Pollard has been very instrumental in the first standards for graphene. And they were based on the early work, and really gives the UK a strategic advantage if everybody can use these standards from a very early time. So this is sort of the life cycle of standards metrology. So going back to our sort of metrology strategy, we've consulted quite widely around this, using different mechanisms and foresighting. And these are sort of the major drivers in materials metrology, and they link very strongly to what Phil already mentioned earlier around metrology for clean energy, energy storage, energy distribution and consumption. All those areas require measurement science. And on the other side, the other theme around digital transition I mentioned earlier, there's a huge digitization going on in industry as well, with virtual design and testing, cyber-physical integration. Phil mentioned robotics, but also brain-computer interface, and then of course the area I'm quite active in new quantum computing technologies, again where lots of validation is required. So what does that mean for metrology? Well, we need to develop metrology at the what we call measurements at the frontiers. So you need to combine measurements from a very large scale on a very small scale. So you grow materials on a centimeter basis, but they are determined at a molecular level. And how do you test and validate that? And then, of course, materials in harsh environments. You need to test the materials in the environment they will actually be used in. And also in complex environments, which, as I said, maybe there might be interference, or the environment might be rapidly changing. It's all those kind of measurements, not in a well-contained 20 degrees vibration isolated laboratory, but they have to be tested where it's important. And then for the smart and interconnected measurements, there needs to be ways of validating the data, the databases which are being used in digital models, lots of testing of self-calibrating sensors, and all these kind of new technologies which are coming around, where you use different types of measurements or hybrid measurements of different types of uncertainty. You have to combine those into an answer. Things like machine learning and AI. What is the uncertainty which comes out of those kind of models? How can you trace that back to the original measurement data? All those kind of things are in this materials metrology strategy to be addressed and to be developed. So here there's some of the examples which are already mentioned. So harsh environments, for example, magnetic materials for the automotive industry. You have to test those under the conditions they are actually being used at the higher temperatures and the stresses they work. Or the electronic or biology interface, so bioelectronics. The human body is actually quite a harsh environment, and testing under those conditions is essential. And then I mentioned multi-scale, so for instance, in the semiconductor industry, or when you grow graphene layers, of course you do that at a very large scale, but the behavior of these materials is determined on the atomic scale, and you need to combine those different length scales in your measurement. And then, of course, the digitization. You want to save money by doing real physical tests, by doing it on your computer. But then, of course, you need to validate those models which you use and validate the data which goes into those models. And there's this increasingly use of data management and reuse of data. And we have to make sure that data is robust. Because if you start off from the wrong data, of course, you'll never get the right answer. And that's sort of the role metrology plays, trying to follow that uncertainty and traceability all the way through a chain to its application. So coming to the last slide, the advanced materials ecosystem. This is a graph I've borrowed from Luc Giorgio from his innovation framework, where the star, where NPL sits in this sort of ecosystem. I think it's really important that we coordinate the activities in the materials world with metrology. Co-location is really important. We've got Andy here in Manchester working with the NGI and the Geek to provide that metrology expertise where it's needed. And then we are calling for the establishment of a national verification center for advanced materials, really to accelerate the innovation and the uptake, commercialization of these technologies.
Any questions for JT?
Rob.
Yes.
Thanks, JT. Excellent talk. My question is about materials verification to support the circular economy, the reuse of materials. Would you like to comment about how your strategy addresses that, please?
The reusing materials is becoming increasingly important. But the sort of measurement and validation techniques which you have to use for those are not too dissimilar to the creation of new materials. So I don't think we're sort of addressing that in any sort of specific way, but it's certainly a good suggestion to maybe call that out explicitly, that is in that way. But otherwise, Stephanie, you can correct me if I'm wrong. I can't see.
We've concentrated on 2 drivers and themes to begin with.
Yeah.
And we've got another kind of 7 papers in the pipeline.
So we can add this going forward. Yeah.
I guess in some ways, one of the questions I have for you is, we talked about a national strategy for advanced materials already a little bit yesterday that's coming out. We've had one for quantum, we've got one for semiconductors. I guess the tricky question is how do these all interface? How do you see the metrology one interfacing with those others or linking to it? And I don't know if you've got comments on that.
We haven't written the metrology strategy in isolation. Of course, we've read the material strategy and the other strategies, and really this should be an integral part of those other ones, because metrology in all these strategies plays a key role, and that's the thing about the coordination and integration of these activities. The metrology shouldn't be an afterthought. It should be there from the beginning, and we have to really try and integrate those.
Yeah, and I think it works the other way around, because obviously you have to look at them as an integrated suite, don't you?
Yeah.
And in some ways, if one's not there, you've lost a key part, but it's looking at that regard. I think sometimes they get looked at in isolation.
Yeah.
Okay, are there any other questions? Yes, Hans.
What sort of activities do you do for really on-site measurement of bridges and structures like that for safety monitoring or lifetime extension? Is that part of your package?
We're starting to look at some of these in the nuclear industry, for instance, at on-site measurement of the atomic waste stockpile at Sellafield, monitoring that and seeing how that, and developing techniques for how to do that in a way which is safe and remote and over long periods of time. I don't think looking at structural integrity of buildings or bridges or something, that's a different type of organization. I think that's BRE who look after that. I think we have not been involved in the Iraq debacle yet.
Conscious that metrology requires also a strategy over data.
Yeah.
Could you speak to that a little bit? Because obviously there's not just the repository mechanisms and the sheer data storage as we continue to generate more and more data, but also data safety, as we've had recently, particularly universities being very vulnerable to data breaches. How does that fit within a strategy of effectively what is measurement and data gathering?
Yeah, so the metrology is particularly about measurement, but it is moving into data, and the data science and informatics is the biggest growing area at MPL for exactly the reasons you mentioned. So developing standards for metadata, developing standards for explainable AI, how to calculate uncertainty in a complex multi-variant system. All these kind of activities are where we do a lot of research. We work with the other NMIs around the world on agreeing methods and standards for data and data traceability. It's a really big area, and it's an integral part of the strategy. Yeah.
Great. Okay, thanks. I think you're off the hook now, JT. Thanks very much. Okay, so just for the last talk this morning, we're going to move back to that technology translation piece, which I focused on yesterday and said how important that is for Royce. We're going to take it from a slightly different perspective this time. We're going to hear from Gillian Davis from Cambridge Enterprise, who's very closely involved in an initiative called Matcelerate Zero, which is really very much around bringing the TTOs together and looking at what capabilities we can bring and interface those and work with industry, large industry, and looking at accelerating and drawing those through. I won't say too much more because I'm going to start giving your talk otherwise. But Gillian is the commercialization director in technology transfer team at Cambridge Enterprise. She's worked with scientists in the physical sciences space, so that's a challenge, isn't it, Gillian? But really around bringing together teams, and working in a whole range of different research areas, but she's got real experience bringing companies through like AgQuat, silicon, microgravity, fluidic analytics, as well as many others, I'm sure. But you've also previously worked, obviously, in industry, so in technical and business development roles in both small and multinational companies, both here and abroad, US and Japan. So a whole wealth of experience. And we're really looking forward to what you're going to say around this initiative, exciting initiative. So thanks, Gillian.